A solid terrain model, STM for short, is an exact three-dimensional miniature replica of a geographic area. STMs are indispensable tools for museums, visitor centers, and for planning everything from industrial projects to military operations. To create a solid terrain model, the first step is to gather data via satellites and aircraft. Two types of data: color photographs of the surface showing the precise location of vegetation, rock, buildings, and so on, and elevation measurements taken with lasers and other equipment. A cartographer digitally merges the black and white elevation diagrams with the color photos and adds artwork for roads and place names. He produces a 3D computer model of the area. This model will guide the machines that manufacture the physical model out of a block of polyurethane foam. Foam is a durable material and lightweight, making the model easy to transport. A computer-guided cutting machine first shapes a ledge around the block's perimeter. This is for mounting the model on a frame. Then the machine reads the computer model's elevation files and carves a miniature replica of those elevations in the foam. The machine first does a rough cut. Then, and this takes much longer, it carves the fine details. Depending on the complexity of the terrain, cutting the elevations into the foam can take just a few hours or several days. When the cutting's finished, the technician cleans off the foam dust with compressed air and a brush. The foam goes into a spray booth, where it first receives a coat of primer to seal the porous surface. Then, multiple layers of special coatings to make images printed on the surface sharp and vibrant. Once the coatings dry, that takes about a day, technicians put the model into a custom-designed inkjet printer, which reads the computer model's photograph file. Just like an ordinary printer, this printer produces a multitude of shades from just 4 basic colors: black, yellow, magenta, and cyan. The jets pass just a few millimeters above the model, emitting 1 microscopic drop of ink at a time at precisely the correct location. The end result is a miniature replica of what the surface looks like in real life. Other workers, meanwhile, construct a sturdy frame for the model by gluing, clamping, and nailing together 4 lengths of oak. This frame will protect the model from damage and make it easier to lift and move. Once the glue dries, they remove the clamps and with a saw, trim each corner to a 45-degree angle. Then they round the edges with a sander. They complete the frame by protecting the wood with a coat of clear polyurethane. When that dries, they spread glue onto the frame's inside edge. Then they position the model so that the ledge along its perimeter sits on top of the frame. After printing, they spray the model with clear polyurethane or lacquer. The protective finish allows people to now touch the model without damaging it. Sometimes an area they're modeling has buildings, bridges, or other structures. When that's the case, an engineer designs a computer model of the object. Then, guided by this model, a 3D printer produces a physical model out of plastic. Building the miniature replica from the bottom up, 1 thin layer at a time. These mountaintop castles in Portugal are the finishing touch on this model that's set to go on display at the local tourist center. Solid terrain models are a creative and valuable tool for educating people young and old. By translating complicated technical data into a unique and scientifically sound visual aid, a solid terrain model delivers a fascinating bird's-eye view from the ground.